So if you haven't noticed, no long intro. I'm done. No more. Um, so you guys heard it was that was fun. I had a very entertaining time talking to Montreal. I like the dude. I hate the chats, and I'm very open about that. But more important things. Me and my friend Digital here. Digital is. I'm gonna send you out the link right now. I'm gonna put the link out in the chat, guys. I'm just gonna give you guys just another heads up on how things go here now. Um, anybody can come on the chat. I'm going to have these panels. How am I going to police it? I'm going to just boot people that aren't here to have the conversation. And that's just the way it's going to be. Again, let me make this clear. I believe I live on a globe, and that's just the way it's going to stand. Um, More importantly, I I am here to understand how everything works, and for that, I use science. If you do not believe science works like you think it does, I really need an explanation. Then we can go on from there. But as I said, I'm no longer entertaining the unimaginable. So I'm going to get the link out there. You guys didn't think everything was going to change, right? There you go. Throw this out there. You guys go ahead and join. Worst case scenario, I mean, if things do get to a point, I can always PMARS another hangout and start from there. And I got the invites already set up, so I decided let's say F it and see who gets in here. And there's gonna be a little twist to it because I'm not gonna just leave it out there for people to just run into and jump on in. All right. So like I said, what is up, Digital? How you doing, sir?
Good day to you, my friend.
Yep. And before we get going, and I actually get into this whole thing, I want to say, first, congratulations to B-Ball. B-Ball just had a baby, so if anyone you guys didn't know and you see him in chat, say, "Hey, what's up, B-Ball? Congratulations! Yay! Another mouth to feed." And I want to say I'm very happy that our friend Crash is here. Crash, I'm very happy that you're here, my friend.
Thanks, Sean.
Let me go ahead and get the run through of what we're going to talk about tonight, and then if you like Crash, we can. I don't mind pushing what I want to talk about back to talk about what you want to talk about. If you want to do that today or you want to do that tomorrow, up to you.
Tomorrow would be better because I'm getting some numbers and paperwork in order for that, because that shit just really pisses me off after this weekend. It should not cost me $15 for a 5-minute phone call home.
Yeah, all the above. And so tomorrow we'll do that because I want to give you whatever time you need, period. So what we're going to do tomorrow is we're going to talk to Crash. If you guys don't know, I'll kind of give you guys a runs up in that if you'd like in a little bit, or do it tomorrow. But like I said, I was talking to Digital and Sean when we were talking about gravitons, basically. If you don't know what a graviton is, it's a hypothetical particle that science is looking for, basically, because it would solidify the observations that they're seeing and the data that they're receiving. Again, I'm just now getting into the what the hell of it all. My buddy Digital here actually has a better idea of the avenues to find the answers I'm looking for. So I do appreciate that, Digital. Again, we've had this conversation, not all of the conversation we're going to be having, but so I'm trying to say it without messing it up. And so if Digital may have to correct me sometimes, Digital, I hope you're ready for that. Because again, guys, I have a basis idea, but I've definitely seen these avenues that I need to be really looking at.
Yeah, as long as you read the indoctrination that I sent you, you'll be fine.
I did. I signed it with blood and sent it out
nice.
On the third Thursday of the third month of the third year. Got it.
Okay, yeah, so you took the Gravitron train back to when it had to be sent, and then you came back via the Graviton wave so that you could then receive the confirmation of you having sent it.
Exactly. Sean, I see you in the chat. I'm going to put because I'm not keeping the links out there, I'm going to put the link in the server, the Discord message, or whatever the hell you call them, DMs. All right, continue on. My bad.
No, you go. You go. You're leading this story.
I am. What's up, Barney? You're going to be proud of this conversation because I kind of think I have an idea of what at least I know about. It's gonna be fun.
Cool. Let's hear it.
Okay, so for everyone that this is my basic understanding of the graviton, as so you guys see where I'm coming from on it first. Basically, with gravity waves, the way gravity waves are registered would be the same way a rock hitting the water and the ripples ripple away from it. There's a source of the gravitational waves, and we are receiving the remnants of the gravitational wave, the ripples that reach out as far into the universe as they can go. For a long time, I didn't really get that because in my brain, again, remember, I got to visualize this in my brain from my understanding. I couldn't imagine how these gravity waves are traveling. Yesterday, me and Digital were having a conversation, and he sent me a link to a few sources, and what really made me realize exactly what's going on with the idea of general relativity and this fabric of space, and this is kind of one of the things that solidified Einstein's idea of this, because you'll see in a second, the way the gravitational waves travel is the exact same way the ripples in the water travel through water. So, in my understanding, imagine the space-time, the fabric of space. Just imagine this. I'm not saying it. People in the chat, is that water, and the way the gravitational waves travel is that water, and that is the fabric, the material, so to speak, that it travels through. Otherwise, you wouldn't have it. It has to be something, or we wouldn't register any of it. Because, again, I think one time I think Barney may have done it, where you corrected me that if the reason we hear is the atmosphere, because it has a median to travel through. That is my best explanation for why the graviton conversation is to be had, I think, and what that means for gravity. Anyone disagree with anything I said?
Yes.
Damn it! All right, what's up?
So, nothing really big. So, one major difference is in dimensionality, right? Ripples on top of a pond are a three-dimensional wave on moving through a two-dimensional surface, right? The surface of the water is two-dimensional. It has no depth. And the displacement of water into the third dimension is what creates the wave.
So
right?
It was my
I knew Barney was going to say this.
It was my illustration to my illustration, or my example of how I imagine it in my head to illustrate what the fabric is your problem.
That's fine. The things which are different beyond the fact that this is a three-dimensional wave in a three-dimensional surface is that the displacement is different. It doesn't just go up and down into that fourth imaginary dimension, right? It changes the medium. It changes the length of the medium in a measurable way. Where does that change go? There are many different ways in which you can interpret that. But we know the geometry of the wave. So it's not exactly a gravitational wave. It literally is the change of space and time, right? It creates local curvature of space and time, which then travels through space and time. In the same way that a wave on the water, as you described, creates a disturbance in the surface of the water, which then travels through the surface of the water. I'm getting tangled up. Never mind.
You just disagreed and agreed at the same time.
Yeah. No. There are. I'm not saying you're absolutely wrong about everything, right? It's just that minor difference of the waves are neither transversal nor longitudinal. It's more complex than that because it's not a two-dimensional wave. It's a three-dimensional wave.
Okay, so
the surface
I get it.
on which the wave is moving is three-dimensional.
Okay, so what you're referring to is almost the same thing as when we get depicted the gravity well, whereas it doesn't sit inside of it.
Literally.
But and not only does it not sit inside of it, but it is infinitely everywhere around it. Everywhere.
Yeah.
Okay. Yeah. Okay, perfect. Because that is very important to say too, because what you guys are looking at right now,
in case of the gravity well,
say again.
In the case of the gravity well, and in the case of this wave, the displacement is symbolic. It is just representing a value in the field, but it is not a real displacement in space. Right?
Yes. It's like we're taking, like if we could take one layer of all this happening around us and pull it out, this is what it would look like. But again, what we're looking at now would be the depiction, but of infinitely everywhere around that you could look or be at all.
In every direction.
Yes.
That's where Sean's analogy is correct about the wave propagation in the water, but you need to think of it in the full dimension of space. So it goes in every direction you can think of.
And that
wave propagates out at relatively the same speed in every direction.
I thought it was, but it's twice. Isn't it like twice the speed of? See, that's where we got to talk about graviton, because this is where I start getting confused.
Okay.
So yeah, go ahead. Yeah, go.
Yeah. So as Barney alluded to, because you have to think of it in that four-dimensional space-time, it goes out, but the time it takes to get everywhere is at the same amount of time.
So say it again, hang on. Say it again, because.
Okay, so the gravitational waves that come from, say, two black holes colliding, the moment it coalesces together and releases that energy that goes in every direction, the propagation time apparently is the same, takes the same amount of time in every direction to get wherever it's going. So it's not like it'll go east, west, north, south at two different speeds. Or durations.
Yeah.
In the same way, when you throw a pebble into the pond, you get a circular wave expanding in all directions. Here you get a spherical wave expanding in all directions.
Yes, and see, that's what I think really is a huge problem, because I searched my ass off for this, an image or something that would depict what we're talking about, and I'll show you guys right now, because this really frustrated the crap out of me doing this, and this is why I think this is hard for people to understand too, because for a long time, this is the best depiction you're going to find of what we're talking about. The problem is, this is happening in, like we keep saying over and over, in infinite directions, infinite everywhere around that. So the way it's going out, it's happening everywhere. It's not just one way, in all directions.
The thing that I was trying to point out, do you see that vertical displacement of the wave in the image?
Yeah, right where my cursor is right now.
Right? Yeah. So it is not a vertical displacement even if you take one slice, right? It is a numerical displacement. It is a change in some value, but it is not that the sheet is being bent that way. Okay. So in that way, it's more similar to, let's say, sound, right? A sound is not a transversal wave as the one which is depicted here. It is longitudinal wave. And if you were to plot the pressure in the air, right, the density of the air as the sound waves propagate through it, you would get a curve the same way as you get here on the screen. But it is...
Okay, I see what you're saying. So
right?
even so
This
what you're saying,
curve
even
is
the
not.
depiction isn't correct either, then, right?
Yeah, the sound is represented in the same way, where you get oscillations up and down, but
Yeah.
what they're actually telling you is more pressure or less pressure, right? It's a graph of pressure.
Okay, I see. Yeah. Okay, I see exactly what you're saying. It's
So
a way for us
yeah,
to interpret what they're describing.
yes. And it's the same thing applies to the gravitational well, right? Where that displacement, it is not a displacement somewhere else into space. It is a displacement of changing a value, like almost like changing the density of space-time or changing the local pressure of space-time.
Do you think like these are better depictions of it?
Yes.
Okay, because this is like probably the best one I could understand what the issue is there for as fast as I could, but so this is much better. This is probably what happens better described than showing the waves.
These are also waves. These are just called longitudinal waves instead of transversal.
But
right?
it's a better
But
depiction of it.
it's also wave, and you can show it with the same wave graph, and it has all the same properties in respect to trigonometry. Like it is still a sine wave. It's just that the sine is not of the horizontal position. It is the sine of density.
But that's
right?
a much better representation, though, right?
Yeah.
Okay. Yep. Just want to make sure. Where's the other? I have another screen I was supposed to be showing. Hang on. I didn't bring it over. Which one is it? It's this one. Yeah. And I think digital. This is you showed me this website or this link, and I started using the website. I'm trying to find everything. It's on a different screen.
Yes, isn't it amazing when you go to a science website that
Yes.
they actually put in links that take you to other science?
Crap, does it? Oh, so I'll show you guys right now. I'm trying to find it right now. Hang on, I gotta pull the screen back up. There it is. Put it over here. Okay, so I love when I find these sites too, because this is one of those sites that like everything like in one source, like in an explanation for it too. And no, you don't have to take it as the only source, but it's a good place. So I'll definitely get the link and put it in the chat for you guys, because god damn, it is a wonderful place. I love this. Is this the one, or did I just take? Oh no, it's not what I wanted to do. All right, perfect. It is. So digital, thank you, because this is, like I said, this is an astronomy site, but it has explanations for everything.
Everything, yes. Also, just an update of the temperature in Adelaide, South Australia. It is 11 a.m. and 41 degrees centigrade.
It's like what, 100? No, 90 something. What 90? What is it?
No, that's
Close.
over 100, man.
Yeah, I'm close. I'm in America. Yeah. I'm sorry. Until you guys
it's about 104
figure it out and start using Fahrenheit like normal people.
Sorry, we don't have freezing at 32.
You should.
Why? Wouldn't 0 be the best depiction of freaking cold?
No, 32. 32 is much
better. 32.
Yeah, I like it.
30. It was 32 degrees at 8 o'clock this morning.
That's not okay.
Centigrade.
Hey, look. That's not okay either way. See? That's what's important.
Yeah, so, but isn't it when you guys get above 100, you go, damn! Well, with us, when we get above 40, we go, damn!
Yeah, well, when you get to 100 Celsius, then come talk to us.
Do you realize that at 100 Celsius, the oceans will boil?
You guys should go to Fahrenheit then. Yep, that just happened.
Nuh-uh.
There you go. All right, so now let's move into the Graviton talk. Okay, so for what people don't... Okay, so again, correct me if I'm wrong, which it's pretty much never, because I'm always right. Just kidding. Let me get this off the screen for a second. It's so much better when people know who's talking. The graviton is in a sense basically the how would you say it? The opposite of how gravity works. Like, so basically explain it, because again,
Yeah.
I don't know how to.
Okay, so you know a
spit it
photon?
out yet.
A photon.
Yes.
Okay.
Right.
Think of a graviton like a photon. So it's energy, massless. That's the theory behind the graviton.
Zero rest
That
mass.
it is a Yep. So it only acts like a mass when in motion, but it's the energy that creates the force, not the mass.
Okay. So in that, see, I have to use this depiction, because this is how only way I know how to explain in my head about it. So it's kind of like for every force, it has another force. John Watson, I see you, and I definitely want to get you in here. Let me see if I'm almost positive I have you. If I have you in Discord, I'll send you the quick link over. I think I do. Yeah, I'm gonna send it to you in Discord if you can get there. If not, let me know in the chat, and then I'll put it back out there. Actually, here, I'll make it easier for you, John. I'll just put it out there and I'll take it off again. There you go. Hopefully you get it in the time it takes me to go. But yeah, what we're looking at now. This is really the only way that it made it clear to me what was happening. So actually, let me ask this question, and I think Barney would probably be the best to want to answer it, because he has I don't care, the devil's advocate of fucking everything. So the idea that and this may be over a lot of people's head, but I need to ask that. I'm a Blue and John. Just go ahead and join that link right there. I'm really not too damn worried about people coming in. Okay, so
Oh,
the
we get
graviton.
blue too.
Oh yeah, definitely Blue. The way the hypothetical idea of how graviton works, or what it is, better yet, is what I understand to be the push of gravity. Now,
Yes, but remember, it has two intrinsic values. It can push and pull.
well, okay, see, I'm confused. All right, let me ask. Hang on, digital. Hang on. Let me ask this question, because it will make sense to you why I asked this question. Then, is it possible that Newton is right? Einstein, general relativity, is right. I mean, and it's that, not until you get to here. No. They're both right. What do you say? What would you say to that, Barney?
I didn't understand what you've said.
Good.
Is it possible that Einstein is right? Yes, Einstein is right within the constraints that apply to. Is it possible that Newton is right? Newton is right within the constraints that apply to him within given precisions.
Okay. Now, hang on. Okay, so in that, what I meant is mass attracts mass, M1, M2, right?
Okay.
Okay, that is correct. No, there's no. Well, if you're here and here, no. Mass attracts mass. Okay. General relativity is the fabric of space-time. The curvature, the bend, whatever you want to call it, right?
Yes.
Okay, that is correct too. In that sense, this is how I understand it. If the graviton were to be found, we would then know for sure that fabric, that in case, how we were just talking about how the gravity well is infinite. Well, that gravity well would then, in theory, if you're looking at it in your brain about it, it would then encase Earth as well, right?
It does.
Okay, perfect. Yeah. So if the graviton is real, or found, we'll say, that encasement is pushing on everything, whereas in the center of the mass is pulling in Newtonian, right?
Just say yes.
Okay.
Just say yes.
I'm just saying yes.
But digital, okay, then you go digital because remember, because we had that conversation, and that's how then I depicted it in my brain.
Yeah, your depiction is actually absolutely correct. Okay, so just listen to this statement and understand it. Newton is correct locally. Einstein is correct galactically. Or universally, but we'll say galactically. Okay, we'll stick to the Milky Way. Okay, we won't go outside until we get back into Graviton.
But if it is locally,
I had different definitions of local and universal. Okay, yeah.
So local, as in the solar system. Mm-hmm. Okay, Newton's right.
Depends where.
Almost
depends
right.
On what depends on what precision. Right. The classical example is the orbit of Mercury. Right. And that expands to all of the orbits. The orbit of Mercury is just obviously wrong by Newton.
Yeah, it was the easiest one to pick out.
But could that have been just like a bad calculation, or
no?
Or no?
Nope.
Okay.
Nope.
It just doesn't work with Newtonian.
It just doesn't work with Newton. Okay. It works with Newton. It's just that when you work it out with Newton and then compare it to reality, those two things don't align.
Okay.
They're not an awful lot, but it's not quite right.
Enough that it cannot possibly be an error or some unknown other influence.
Right.
It's just
right. It's not
wrong.
It's not a measurement error or something like that. There's something wrong with the.
Okay.
With a
drop a hammer, Newtonian. Okay. Explode a star, Einsteinian.
Yeah, fair enough. Yeah, let's work with that.
But they could both work in this. But see, that's what I'm trying to ask.
No. That's what I mean by local, right? So the drop of a hammer or the orbit of a moon around a planet, right? That's local, right? But an exploding star somewhere else, that's Einsteinian.
Repulsive particulate gravity, Lesage theory, right?
I don't know what you just said.
Yes.
Yeah.
That thing that you were describing of gravitons pushing away from something and therefore making it, that's called the shadowing theory or Lesage's theory of gravitation. Lesage.
I'm trying to find that website I just had because I think it talks about that.
I like to think about it like this, Sean. A 5/8 inch socket will work only on one thing. That's a 5/8 inch bolt head. A crescent wrench will work on anyone. So Newton's kind of like the crescent wrench of gravity, and Einstein's like the socket set. How's that?
I got
it. Make any sense?
Yeah. Okay, I get it now. But
analogy central.
I need those.
Okay, or idioms.
What did you say? Damn.
No, not idiots. Idioms. Idioms. Okay, like a passing phrase that equates to something. like oh, bless his heart.
I get it now.
Which means anything but that, right?
Yeah, that's right. That's an idiom.
I get it now.
So Blue, in your analogy, what would the 10 millimeter socket be? Would that be the black hole? Because it's always missing.
Huh?
Oh, that's the unified theory.
Yeah, that's pretty much what it is. Yep, you can't find the damn thing. You know there is one, you just cannot find it.
Yeah, it's all right over there, right?
What was it? Damn, I'm trying to remember. I was watching. What was that? I was watching that the YouTube link that you sent to me earlier, digital with the what is it? Gravity Day or whatever they called it. What was it? See, I have all these depictions of it, and I don't want to use any of them now.
No, like all of those depictions and illustrations are okay. I'm not telling you they are wrong, don't use them. I'm telling you you have to keep these things in mind when you look at them, otherwise they might mislead you, right?
Okay, yeah, absolutely. Um, see, I didn't find one. I didn't find one in here in this site I'm looking at. But like I was saying a second ago, why don't they have anything that depicts it better?
Because we can't draw in 4D.
We can't. Yeah, I guess I can't ask if they can do it if they can't. Damn.
Hey, Barney, it's John. John, what's
Hey, John.
all right? There's something that's always kind of bugged me about the kind of media representation of black holes, and I've tried to talk to a few people about it who were not as much of a space geek as me. And I'm thinking that you maybe are as much of a space geek as me. The common depiction in the media is that black holes are dark because light does not have sufficient velocity to escape. And it's actually my understanding that there is no escape velocity in a black hole, because time and space are warped so much that there is no way out. All routes lead further into the black hole.
So the all routes that lead into the black hole is a specific metric that happens beyond the horizon, where all space-time dimensions become time-like, and all time-like dimensions become space-like. So within the whole, all, like, you're in what was it? Singularity is as inevitable as tomorrow, right? You will get into the middle, but like if you want to go a bit more, like not so abstract as that, it's the frame dragging issue, right? A black hole is not a stable displacement of space-time. It is not merely a deep well or deeper than others. It is a well which not approaches, but as you approach singularity, the well becomes infinite. It doesn't have a bottom. It doesn't have a bowl. So it sucks in more than matter. It sucks in space-time itself through frame dragging. And the light that is kind of escaping away from it is fighting against a current of space-time falling in at faster than the speed of light, so it cannot possibly escape. Does that make sense?
But that's beyond the event horizon.
The event horizon is literally the place where frame dragging becomes such that the space is falling in at the speed of light. Yeah,
that's what I mean. It's really funny. Whenever we talk, we're saying the same thing, but it sounds like we're disagreeing.
It's not. Again, it's not a disagreement. Same thing as with Sean. It's not a disagreement. It's a statement of, if you state it in these 5 different ways, the truth is somewhere in the intersection. But that intersection itself is so unintuitive that I can't just say it in a sentence.
But it is true though that the reason why light cannot escape is not because it has insufficient velocity.
No, it is.
No,
the light itself does not have sufficient velocity to escape the black hole. It does fall in because it cannot escape out, because the space around it is falling in faster than it moves. That is what turns the dimension of space to become time-like, so that you cannot avoid the singularity.
But equally, if space is turned in on itself to such a degree, it doesn't matter what your velocity is. You wouldn't escape.
Yeah.
So it doesn't. It's not. It's this sort of reaching to the everyone thinking that the universal absolute speed limit of the universe is the speed of light, and it's something like extraordinary. But in fact, it doesn't actually matter, because even if you could travel faster than the speed of light, you still wouldn't be able to leave a black hole.
Yeah, so let's say there are hypothetical particles that can move at twice the speed of light somehow. We don't know what that means. That mathematically makes absolutely no sense, but let's just say that like just declare that such a thing exists.
They go tachyons or something.
Let's say a tachyon. That thing could also not escape a black hole. It would just have a smaller event horizon.
Yeah, the event horizon would be closer to the center of the black hole.
Yeah.
Yeah, I thought you'd say that.
Yeah, and like, so would that all be dependent on the size of the stellar mass as well inside that black hole?
It's no longer a stellar mass. No, I mean, well, Barney.
The mass determines how far away from the singularity is the event horizon, right? That's the only thing that it determines. Another thing that is determined by that is, like, as you approach the singularity, the tidal forces increase. So the mass will determine how violently you will die, basically.
So how much spaghettification will happen to you?
Yeah, how strong the tidal force will be and how fast you will reach it. In a small black hole, that would be almost immediately, and in a very large black hole, like, you might not even notice that you have crossed the horizon, and spaghettification will happen at the very last instance, but you will be long dead before that.
Very long.
Literally from old age.
Yeah, you would age rapidly before you actually died. That's actually Hawking came up with that idea.
Yeah, so as you get into that frame dragging, as you approach the horizon, like if you're looking from the outside of a black hole at somebody falling in, they're, due to general relativity, as they're approaching the gravitational field, their clocks will tick slower and slower and slower from your perspective. So much so that it will stop. It will, before they ever reach the event horizon itself, their clock will stop. They will seem to move at the speed of light, meaning that their clock won't tick, right?
From an observer's point of view.
From your perspective, falling in, you will see nothing really odd. But before you cross the event horizon, the universe outside will expire. Literally, all of time will have passed in the universe outside. Though for you, there will be a next second in which you cross it. And if the black hole is large enough, you will just go through it. The black hole will slowly evaporate, retreating in front of you. And as you speed up, the event horizon will retreat, always keeping one step ahead of you until you reach the point of just being burnt by the radiation. And that's going to take an infinity of time, effectively. Trillions of trillions. Wouldn't that mean that the event horizon is faster at this? The event horizon is as much of a real thing as the real horizon.
So it's apparent. Yeah, it's apparent, Sean.
Right. In the same way that your horizon becomes wider when you get higher, right? The horizon gets smaller as you approach it, and depending on the speed at which you're approaching it.
No, you can't imagine it because it's it's beyond the capability of the brain to understand exactly what would be happening to you when you're there. But the explanations we have from all the physicists from Einstein onwards that have looked at these things, not directly because you can't see the bloody thing, but you're there, event horizons and what happens. But the explanations that get too close
or something like
and all
that.
these sorts of things, these are the best explanations of what can happen.
The sad fact is that if we were actually, for argument's sake, in a spaceship near the event horizon of a black hole, we would be in the middle of nowhere, and there would be nothing to tell us which way we were traveling, what was happening.
Yeah, no frame of reference. Yeah.
No, so it's like these beautiful nebulas that you can capture through a telescope. If you're actually in the middle of one of them, you probably wouldn't see anything at all.
at all, like you would hardly detect that there is any gas there.
Yeah, I mean the density of gas in these beautiful, colourful nebulas is very, very thin. The space is vast, and it's very empty to the human eye if you're actually there.
Yeah, but that'd be like saying like how we see the nebula is the same way we see infrared, though. The temperature of surface of everything.
It is, but if we're looking at a very, very small concentration of sky, even through a telescope, I mean, you're looking at something that is very bright, but it's many, many light years across. So if you're actually in it, and say like our solar system, the furthest reaches of our solar system is maybe like a light year across or something. It's a huge area, and it only appears to be something if you are very far away from it.
I get what you're saying. Yeah, okay, I see what you're saying. We're okay. If you were there, it wouldn't be a star. It'd just be you. What you're there. It'd just be. I get it. In a sense.
Like if it's just a very, very, very faint mist in I don't know, illuminated by a light. If you're looking at it from far away, you can see it as a cloud of illumination. But if you're under that light, like you just literally can't see anything. It looks like it's clear. But anyways, you were trying to you opened this up to tell us your understanding of a graviton.
Yes.
Do it.
All right, I'm gonna try.
Can I just say something first, John?
Yes, absolutely.
I had my first walk today without an aid.
Fuck yeah! Congratulations, my friend. That is awesome.
It's bruised as fuck.
It hurt. It hurt, huh?
Yeah, it did.
Did you just say that you had your first wank without an aid and you're bruised as hell?
Wow.
Barney, really? You went there?
That's what I heard. Sorry.
My leg has been in plaster for 3 months. It was the first time I had walked on the ankle without crutches or a scooter.
I just heard the word wank instead of the word walk.
You had pareidolia of what I said. You heard what you wanted to hear.
Wait, were you at?
I thought you were human for a second.
Wait, Barney, were you at Jose's stream earlier? Because I think that's contagious. I think BB may have given it to you. The pareidolia.
Oh my
No,
God.
Barney doesn't need any help.
I can do it all on my own without any help. Though I do end up bruised sometimes.
Okay, before I start my, or actually, go ahead, Digital, because I don't want to go off topic, but I have something to say about BB later. Go ahead.
Yeah. Anyway, we'll bring it back to the graviton, right? Now, there was a little something. If you actually read the article with the graviton, because it's hypothetical but theoretical at the same time, that you can make certain statements about it, and no one can turn around and say you're factually wrong.
Well, I like the idea of the graviton because it gives. Well, for one, it kind of adds to what we know about, and I hate talking about this because it pisses people off, dark matter and dark energy. Because in my opinion, and I may be wrong, but I think the graviton is another piece of an aid or tool that helps explain what these things could be. But to me, in my brain, it makes more sense because when they do start talking about the dark matter or dark energy, and they talk about how the expansion is because of that, it makes the graviton, to me, in my brain, that makes more sense to me. And like I was saying, my understanding of a graviton would be, like I said earlier, I think Digital, you kind of corrected it a little bit better, but for me, it's the push of what the gravity pull we know. That's the only way in my brain I can really have an idea.
It becomes the opposing force to the pull of gravity, but it does intrinsically have both properties.
And then also I wanted to ask, isn't the graviton also because of our element, or the particles that we know and how they work? We kind of all see them as having a negative. One has one side and the other side, yin and yang, quote unquote.
Basically, positive and negative, or
yes,
a positive and a neutral.
Yes. And the gravitational force is one that doesn't, right? It doesn't have. It has a weak, but it would need a strong. See, that's where I get confused because I'm still learning this.
It doesn't. It has a single charge, right?
Gravity.
It is monopolar.
Yes.
Okay. Not the graviton.
Not the graviton. Gravity.
Because it has two spin.
We're not talking about spin, I think.
No.
We're talking about charge.
I barely know what that is. Okay, so when you say,
I think Barney needs the paper.
Well, you're saying when he said it's one directional. You're talking gravity, not the graviton. Whereas the reason they think that they even hypothetically thought about the graviton is because, as we know it, particles usually have this anti or negative to its positive. Correct? And that's kind of what got them.
Yes, we're talking about charges. Okay.
Yes. Yeah. So that's what got them kind of going. There's got to be. Excuse me. There's got to be, but we need to figure out a way to observe it. Find it. Whatever. It's other half basically. So that's why I like it a lot because it gives it. It really blew my mind yesterday, and I'm telling you this as real as it gets, Barney. The fabric of space made zero sense to me until yesterday when I was talking to Digital and we were talking about the gravitons and shit, and the idea that something, like all these things that we're registering are traveling through something. What is that something? And that's when the fabric went boom. Okay, I get it now. Or I don't get it, but
space and time. Okay.
Huh?
The fabric of space and time.
Yes, I finally got a visual for it in my head of how it kind of works. That's why I was saying the ripples in the water, because it made more sense. And I do understand it's everywhere, all the time, infinite direction. And I'm going to say that every time we talk about it too.
Okay.
Now, I know I didn't even give you much, but that's my basic understanding of why the graviton is in a hypothetical or even a theoretical stance in science right now.
So from what you have described,
yes,
I everything that I've heard smacks to me of Lesage's theory of gravitation, as though you're imagining little billiard balls which are constantly showering everything and pushing things together.
Okay, yeah, and that's what I got a question about, because actually I was watching something Grim had told me to check out, and it was I think it was titled like the gravitational model or something, by something Thompson. I forget what it was, but in it he kept saying that he was saying he was like disproving the graviton, but because of that, whereas like I don't know, it was so weird. I don't even know, like it really effed up my brain. But he kept saying that if the graviton was real, that it wouldn't have a push pull, because all the gravitons would just clump together, and then nothing else could happen. And that made me like, what the? I don't get it.
So, okay, there are a couple of things that we need to cover there. One of them is charge, right? With electricity, particles can have positive charge or negative charge. They communicate that charge to each other with a particle called a photon, which has no charge. Right?
This is like
it
what
is
we were
not
talking about yesterday, Digital, when we were talking about welding, right? It's like that.
Yeah.
See, I don't want to mess it up and say that, well, the way the volts, amps, and current and watts are is basically the same idea.
Yeah, how you turn volts to current to wattage. So that order, you don't go backwards.
Okay. Continue, Barney.
Yeah.
Sorry about that. I'm just trying to.
But Barney's correct, because of the oscillation between positive and negative charging. It does have to send a photon between it to talk to it.
Okay.
As it were.
Okay. My bad. I just wanted to clarify. Go ahead.
For a positive particle to know that there is another positive particle to repulse against, it needs to exchange a photon with it. For a positive particle to know that there is a negative particle that it needs to attract to, it needs to exchange a photon. Same thing, right?
Okay.
That photon communicates in its directionality what the charge is and how they interact. That photon is not a billiard ball. That photon is a wave of something that communicates an energy. It communicates a vector. It communicates an energy and a direction. Now, that is if you're thinking about it as particles. Another way of thinking about it is with fields. In fields, there are no particles. Every point that can exist has a value for every force, for everything, including the electric field. And depending on what's next to it, that value can change. There is a disturbance within that field that propagates at the speed of light, that carries that information, and that disturbance is what we call the particle of a photon. And that particle can then convey either an attract, and it carries real energy and transfers that energy to the other thing. And then that wave, when it interacts, when it interferes with the waves of the charged particle, transmits that energy, pulling it in one direction or the other. It's not billiard balls, right?
Yeah. Okay. I see.
In the same sense, with gravitons, a graviton is just the carrier of the information and the energy of a gravitational field. It is not a billiard ball. It doesn't have to hit on something and rebound. It doesn't have, like, the charge of gravity is mass. There is no negative mass. There is no positive mass. There is no different type of mass. There is only mass.
Well, that's also why.
So all that the gravitons communicate is the distance, or the amount of nearby mass, right?
Okay, so I'm looking at it as a direction where it's not a direction. It's the energy behind that direction, or that force, or whatever.
Yeah, the property of the propagation.
if you look at it in that mechanical wave, that disturbance in the gravitational field that tells the other object, hey, here is some energy to go in that direction, is the particle called graviton.
Okay.
Right?
Yeah, so
And it doesn't, and
continues
things
to
don't
move
have to behave like billiard balls where they
Are attracted
ricochet
to,
off of each other elastically, or like the graviton in that process, the graviton is absorbed. It doesn't exist anymore after that. It has transferred its energy.
And that's why they believe they can't find them, or they haven't been able to observe them.
So the reason why they haven't been able to observe them is because they carry such minuscule amounts of energy individually, if they exist. Like,
yeah, it's
compared,
this is like it's on the quantum level, but in terms of the understanding of everything to be able to find it, I guess. Is that?
Yeah. Well, did you read the measurement that they had for the size of this theoretical particle?
Yeah, I don't understand it. I don't know what 2 times.
Okay, so if it said it was 10 to the negative 23,
yeah,
right?
Uh-huh.
A Planck length, which is the smallest known measurement to man, is 10 to the negative 31 times 1.6. Right? That's the smallest we can physically measure.
Okay.
Right? So this graviton is smaller than a gluon.
Okay.
That won't mean anything to him. Yeah.
Well, that makes sense to me. I know what that is, so that makes sense. But so
that's how small it is to detect one particle of a graviton. How do you see it to know that it exists?
So even in the hypothetical or even theoretical sense of the graviton as we know it right now, they understand it really is a technology thing, if it is even a thing.
Yeah, but it is a matter of scale, right? Theoretically, very hypothetically, you could build a contraption which would be large enough to detect gravitons through direct observation. You would need a particle accelerator. I think that the radius would be slightly larger than the radius of the visible universe.
Okay, but that's like saying we'll never be able to see an atom.
Yeah, it's kind of like let's say you have what is it? A sandblaster. Like, do you know what a sandblasting chamber is?
Yeah, absolutely.
So for machining steel, you have those with lead shot, which will strip practically everything off of steel, right? Now, imagine that you throw in a styrofoam ball into that machine and try to determine where the styrofoam ball is in that shot that is getting shot out of the cannon constantly by measuring the movements of the shot. Like the comparison between the thing that you're using to measure and what you're measuring is so staggeringly difficult that it's not merely daunting. It is.
I get it, but I have faith in science.
So,
Sean, I can only get so erect.
So,
I don't
ways.
know if I posted it. Hang on, Barney. I don't know if I posted it to you, Sean. But Fermilab were at the dark matter detection laboratory.
Yeah, that was that video I was talking about. Where they it's Gravity Day or something there.
Dark Matter Day.
Yeah. There you go. And yeah, they're having whatever you're having. Whatever you just said you were having, they have.
Oh, they could only get so. Yeah, they could only get so happy.
Yeah.
But the amount of different instruments they're using to detect particular intrinsic parts of what they believe dark matter to be, which is the axions, the gravitational force of the dark matter, That's why it's under rocks. So because dark matter works like neutrinos, it goes through everything. Okay, but the sensitivity of their detecting stuff is it's phenomenal. They're using crystals at super cool temperatures, like 13 thousandths of a degree above absolute zero, to be able to see one little particle go through the crystal and make it fucking vibrate.
Yeah, it's too deep for me.
Yeah, well, it's actually like, you know, a couple of 100 meters below rock is where this detector is.
Pretty crazy. Yeah.
Yeah.
It was weird because it was what it was a YouTube video that he shared, and if you watched it without sound, you would think it's a mine, and the dude's just letting you know that what a mine's like, because the dude's just dressed like a construction worker. It's weird, but he starts talking, and I was like, oh shit.
What, did he science the hell out of you, Sean? Yeah. Huh? He scienced you.
Yeah, he did. It was crazy. I'll share the link. I don't want to play it because I'm actually. Hey, whoa! Holy shit! Fuck that! We're playing it. You want to know why? I'm no longer monetized.
Because you can.
Yep.
Yay!
All right, I'm not gonna play the whole thing. People, trust me. It's not that. You won't. I can't do that. But
you can still get copyright strike.
Yeah, but that only happens when they don't want you to do it. I'm telling you now, these people, they want it. They want the publicity.
Okay.
Yeah, no, I'm not worried about it like that at all.
It's Fermi. It's Fermi Lab, Barney.
Yeah. Let me see. There's one thing about gravitons, like we keep talking throughout this show as though they are likely to exist or they do exist, we know what they are, and we just haven't discovered them, or that they're deductively necessary. No. Gravitons are not even hypothetical. They are hypothetical. They are what properties would it have if the force of gravity was a bosonic force like all the others? Like if we make some huge assumptions that have no indication other than, well, it worked before, maybe it could work again.
I'm gonna say,
you mean make an assumption and then see if you can find it?
Yeah, but
the
assumption includes in itself the statement, and you're not very likely to find it.
This is
if the assumption is right, we're not going to find it.
This is almost exactly what Barney's saying. The stuff. Okay, if we were walking through the woods and we saw a log that looked like a mythical creature, that's about where we're at. But we haven't even seen it yet.
Yeah, actually, here's one that is basically what Barney's talking about.
I like analogies. I'm not sure if you guys noticed or not.
Yeah, remember the guys that invented flight, Orville and Wilbur?
Yeah.
Right? One of them said they would never break the speed of sound. He was alive long enough to see them break the speed of sound.
Well, Barney here doesn't think they're going to have the tools to be able to see measure or see a graviton, and I say they will. And I may have a false claim, but that's what I heard.
Yeah, Barney.
Who says there's no controversy in science?
Based on known physics. So yeah, of course people can invent new things and discover new things, right? I'm not saying it is in principle impossible. They will never in any way, right? But I'm telling you why it's so hard. What the obstacle is. The obstacle is that the energy of an individual graviton would be so immeasurably small that you couldn't indirectly measure it by decay because it wouldn't couple to anything other than a graviton.
Well, under today's standards, maybe, Barney.
It didn't understand a word of what I was saying to say that.
Yeah, we did. Yeah, we did.
No, you said the energy that a graviton emits is too minuscule for us to measure.
No.
Okay,
No.
go ahead. Say
That's
it again
not
then.
what I said. To indirectly measure through coupling. Do you know what a coupling is?
No, explain
Yeah,
it.
that's what happens when you get in bed with a woman, isn't it?
Or a couple of women.
No, that's multiplexing.
That's multiplexing.
Yeah.
Uh-oh.
Yes, we've descended.
I knew it was going to happen.
Yes, it was also, even in principle, impossible to detect atoms by visible light because we know what the frequency of the light is and what the size of the atom is, and then they did it.
And you're saying that they don't have, because we don't have the size. Well, we obviously have a size. We know it's just small.
Yeah, but we've got the atom, the proton, and the neutron to quark interactions with gluons.
And I'm pretty sure the Wright brothers didn't think we'd be able to do that either. Barney.
Yeah, and nobody ever detected quark
Oh, okay. Well,
directly.
Detected who?
and also, I understand
quark.
you didn't say we will never be able to. You just keep saying we can't. And I'm an American. I'm sorry, but
I'm just saying that it's very, very, very difficult. I'm just saying that it's very, very, very difficult.
You should call DARPA. DARPA's whole motto is "Do it DARPA hard," and I'm not joking at all. That is really their motto.
Yeah, I can't believe an antenna array caused such a conspiracy. Well, because it puts a blast into the ionosphere.
But it does things, though. No, hey, I defend that one, Digital. I will.
Hey,
No,
you can defend it as much as you like, but my Hills hoist, which is made of wire, doesn't do the same thing.
Okay, well, first of all, they do not control the weather with it. No, but I can definitely see how they can. Okay, if the 3.6 million watt array or whatever they got, if it is able to produce that much power, I could see how they could change some shit. Just in the fact that it does.
It can't.
It can, why? Okay, so what makes rain? What makes weather?
It can't produce that much power.
Okay, they say it does.
No.
Who's they?
Okay, I'll show you the paper right now. Oh,
who's they?
And everyone was like, "Uh-oh."
Yes,
Sean's
because
gonna
the
be
measurement of broadcast power is used as though you're broadcasting in all directions spherically equally, as though you're using broadcasting, right? That's not what HARP does. HARP projects linearly in one line up.
Yes.
Yes.
Thank you, Crash, for the giggity watts.
So if they were projecting that much as they're projecting directly up in that square area that they are, if they were projecting that in a sphere in all directions, then they would have the gigawatt power that's getting that is the listed value. 1.22 gigawatts or something.
I'm trying to find the paper that says what they're putting out. Hang on. Okay, so it says HARP projects project directs a 3.6 megawatt signal, or was that megawatt? Let me make sure first. I hate these stupid things. I'll show you guys what I'm reading.
My number was clearly from Back to the Future.
Go back and work on your flux capacitor, Crash. We got to have that thing.
Why do I got to work on something you can literally order from Advanced Auto?
And again, this is just a quick, search for what I was looking for. So this isn't like I know because Wiki told me. But yeah, this is what I was talking about.
3.6 megawatts is not a lot of power.
Yeah, Sean, we don't care if you use Wiki because it's a good way to get you to the information you require for a quick
Well, yeah, this is
presentation.
like I have other stuff, but this is like as fast as I can get to something. Like you guys can, you guys can see it. Like this is what I have stuff
Yeah,
on heart, but it's just I
is that
define
in
what I'm looking for.
megahertz?
But that's the
Is
thing.
that
I don't
shit in
know. Yeah, you're
megahertz?
right. I don't know those things. That's why
Then
you
I
guys are.
shouldn't. If
That's
you've
why
done
you
that much
guys.
research on
That's
harp, then I
why you
shouldn't have
guys
to
are here.
explain this
Well,
to you.
yes, you should because I may have read it differently. I may have seen it differently.
Okay.
You know what? Just explain it, okay? I'm not gonna tell you so just be happy with that.
Yeah.
Yes,
Proceed.
the output power is 3.6 megawatts, which is not a lot of energy.
Okay, well, here's
Right?
the better part of why I
It
thought
was-
it was. Because when I first found out about this, it wasn't a media report talking about it, and it put it as the million watts. It didn't
Yes,
do that.
it
And
said-
that's what projects to make me think that is a large amount.
Yes, because it was listed as 1.2 gigawatts of, and I forget what the specific term is. But if I Google 1.2 gigawatts, I'll find it.
And for the
Over
record,
there.
Me looking at, like talking about these things and not just full force running into it. That's why I know they don't do the weather stuff. Trust me, I backed off because I started listening about and understanding more what I was reading about it. So don't kill me for it. That's what this is for.
No, I'm not killing you for it.
I'm just saying in general.
Yeah.
I'm jumping on you because you said, no, I know what they're doing. I know that they can do this because they're using this many gigawatts. No, they're not.
In a sense of, okay, now hear me out on that part because this is what they do in Abu Dhabi. Whereas in the idea of how this works and the idea of how cloud seeding works, they use the ions in the air and excite them, and that starts making shit happen. And it's in that sense of that's what I was talking about. But what you were saying,
do you know what
it's very directional, and I was thinking in my head, well, when you look at the different atmospheres, layers of atmosphere, well, weather and depressions and all that stuff, like the high and low pressures, all they start when things start happening from higher up that we don't see on a regular basis, or sometimes don't even affect us at all. That's what I meant. I wasn't trying to jump straight into a conspiracy theory. I swear, I promise you.
Yeah. Sean doesn't do
It's
that
not
without due
3.6,
diligence.
though.
I try.
It's a 3.6 megawatt signal,
Mhm.
and it outputs 13 kilowatts.
Yeah, and do you know why they try to do this into the up above the troposphere? Do you know what it's for?
Yeah, it's to
do you know
block and transmit signals.
Or disrupt a plane.
Yeah. This was the real reason HARP even started. Their idea was when they did the whole control of the skies and all that shit, they were actually just talking about radio communications. If they can't talk to the other people, we're in control. And if we can get a message to someone further than we could 20 years ago, then we win. That's what that shit was about. I get it. I get why. That's why I know it's directional and all that stuff. I know the tracing and bouncing. I know. It's amazing. It's actually it's a really good story if you really look into it. About
now I'm waiting
what
for you
it
to
is.
light up a smoke and go, Mulder, you don't know what I know.
I want to, but I can't smoke in the house. So wait. Hang on. I was well. Now I'm talking about marijuana. I can do that right here. I'm sitting. So ha ha ha. Yeah, no kids are here. So ha ha ha. Continue.
Go, Sean. Huh?
Hey, wait. Blue?
Hmm?
Oh, why don't you
What?
speak up? I know you're pretty smart in this stuff too, man.
How did we end up talking about HARP? Weren't we talking about gravitons?
Oh, geez, were we having a conversation about all sorts of things, though, Barney? Like, what are you, a flat earther? Gotta stick to the subject, man. Come on.
I can't say that, and neither will you guys. And I can't say for other reasons. They're listening. Okay, so yeah, but I don't know how we got to HARP. I really don't.
Look, guys, my handlers are going to smack my fingers, and I won't get my shill money this month. Let's stay on topic.
My show next year after this week. Just throwing that out there.
Yeah, and again, tomorrow, me and Crash I'm gonna do a live stream with Crash about his weekend because if you haven't heard, he had a pretty shitty ass fucking weekend.
A pretty shitty ass week.
Now, listen, I have my opinion about this, and it goes on both sides. I haven't even talked to Crash about it yet, and I want it to be fresh because Crash is a pretty mean dude sometimes. Anyway, just kidding. But what happened is it's some fucked up. Wait, some fucked up. Who gives a fuck shit? I don't care what side you think you about shit. He got fucked this weekend. In mad respect to his
bureaucracy.
Yeah, mad respect to Crash's girl, and mad respect to her Crash because she really reached out.
That's Mrs. Crash to you.
Well, I'm gonna say Crash girl. Crash is my friend. That's what I would say.
Yeah, but it's still Mrs. Crash.
Yes, it is Mrs. Crash.
Mrs. Crash.
You don't have to fucking dox her.
What? By calling her Mrs. Crash?
Yeah, I mean, well, I don't run around telling people.
I don't know where Crash lives. I don't know where she lives. I don't run around
saying to everyone I know Crash because he's Crash and shit. Maybe she doesn't want everyone to know, that she's with him. I mean, she may love him, but she doesn't want everyone to know. I wouldn't want to be seen with him either.
For the live chat, bro.
What?
She's already blasted it all over the YouTube chat.
Oh, okay. Yeah, I guess she. And she's Mrs. Crash too, right? Wait. Time out. I have a better thing to say, and I was reaching. But Crash, can we go on a campaign and see if we can vote your screen name to be shorter?
I guess we can do something about it. I'm getting ready to change it anyway, but
to Crash. Crash's RC is good enough.
Yeah, I'm going to change it. So I'm going to take my other channel that I'm working on in a completely non-flat Earth direction after this weekend. Let's just say that.
Oh yeah, that's. You didn't hear my stream? Oh wait, you didn't. Damn, I feel bad.
Yeah, so that Crash was incapable of hearing that one.
I'm not gonna lie to you. I just realized it. I'm not going to talk on it. I cannot talk about it anymore. It's just not going to be talked about. Crash, I suggest you go to my farewell to somewhere, and there you go. So we're going to move on now because, again, no more. Here we go. Gravitons.
How's your Gravitons, eh?
Okay, so I think where we left off was Barney saying that
I need to make the disclaimer.
That's fine.
Yeah, I need to make the disclaimer again.
Mm-hmm.
With the Graviton, any assumption, assertion, or thing you say about it, you cannot prove to be factually wrong.
Holy crap. Did you really just say that?
Yes.
Yeah, I know why you said it, though. It hurts me.
Because we don't know.
No. He's just, that's a troll comment.
Well, actually, it's not a troll. It's the fact that this is where... Actually, there's someone in the chat who's got the perfect name. Mm-hmm. We need critical thinking.
Mm-hmm. Okay,
so if you think critically, you're not going to make a wild ass assertion about it. You're going to think like, what does it equivocate to? So you make an equivocation, which there's nothing wrong with that, right? Then you think about some form of causality, like what could cause this? How does the event happen? What does it do during the event? What happens after the event? And you think all these things, but if you don't think that way, whatever you say, people are going to call it bullshit because it makes no sense.
Mm-hmm. Well, the idea that's the thing about, because as far as I'd ever known, because I've heard about the Graviton a long time ago, but and to me, it was like, that doesn't make any sense. Why are they talking about it? It's like, because they make it very clear. Hypothetical. See, I think, Digital, you said theoretical, but I know it as, and I only heard it as a very hypothetical thing. In a hypothetical sense of, well, these particles and everything interact with things this way. Well, there's got to be this thing that does it. And they just gave something a name, an idea name, basically.
Yeah, but is theoretical physics a fact?
I don't know. Is it?
Yeah, burn.
That's not a burn. I don't know. Tell me, asshole.
Well, in theory, it is.
Sean Smith.
Brilliant.
Brilliant. I don't take everything like that. So it's just fact all of a sudden. Especially here, because Barney, like I said, Barney that a couple things you said to me just kind of always stick, and it's like we're talking about it, but we're not talking about it. You know, you were saying everything is a philosoph is all we're doing is being philosophical about science, but then in a real sense, we're really not, because who the are we?
Yes, we are.
No, we're
Yes,
not.
we are.
No, I'm not. You guys are. I'm not. I'm still learning.
No, we're laymen, all of us,
Yes.
giving commentary on the information available to us. None of us is doing this for a job. None of us is doing any research. Nobody's going to perform experiments trying to find the graviton. Nobody has the mathematical understanding of the underlying theory.
Wait. What if I find the graviton? You can't just say I'm not going to. I mean, I'm not looking for it.
No, you're not currently in the process of.
Okay.
If you learn the maths and learn the underlying physics and then go on to be a
Okay.
research physicist, then
Well-
you might find the graviton.
Okay, well, check this out. Check this out. I know that a gluton is what holds an atom together. Everything about an atom together. Now, knowing that.
Wait, what?
Hang on. Yeah, the gluon for particles. That's how I know that part. That's
Holds what together?
an atom. All its stuff.
Nope.
Why? Tell me where I'm wrong.
Gluon holds
Yeah.
the quarks together. The quarks create the proton. Then
Yes.
you have the protons and the neutrons in the atom.
Okay, yeah, that's what I meant. It holds shit together.
And then you have
time
the
out.
pion
So what you
interaction,
guys-
which
wait,
creates
hang on.
the
Hang on,
overflow
Barney,
of the
because-
strong force, which holds the nucleus together.
Well, hang on. All of you on this panel have known me for about as long as I've been trying to teach myself particle physics, and I say try now. Why, do you believe that I will ever achieve enough knowledge to find the graviton?
No.
Damn. Okay, never mind.
Well,
Okay, got it.
It's not impossible, but you asked me whether I
no.
believe that you will, and I don't.
You know what? I don't believe it either, Barney. And I'm going to say right now, I'm going to say this. Even Slick would say he believes I'm not going to.
hang on.
That's how
The
sure
best
I am.
analogy. I've got an analogy for you, right? You know how there's carbon in the air,
Yeah.
right? In the form of carbon dioxide,
Mhm.
right? You can't just get your hand and grab that carbon out of the air.
Bullshit. Because it does not
Grab
travel.
a bunch of
can't.
coal
It does
out
not
of the
travel.
air.
It does not travel through my hand. Therefore, I can. Boom.
No, because once you close your fist, how do you know it's got carbon in it?
Oh, there's carbon everywhere.
Yeah, but
Because
how do
science-
you
Science
know
tells you
there's
there's carbon in your hand.
Yep.
yeah, but can you see that carbon?
Oh,
No.
we didn't
The
say
carbon
anything
you grabbed out of
we
the
didn't-
air,
hey, we didn't say nothing about
can
seeing
you
it.
physically see it?
No, we
No.
didn't talk about seeing it.
So how do you know it's there? Yeah, but this is the thing.
Because science
Hang
can
on,
tell
Sean.
you in how much would be in an area that would encompass your hand.
The
at that
size of your
time.
fist. Yeah. Yep. Exact same thing with this hypothetical, theoretical graviton.
No, because we can.
Hang on.
Wait. I'm wrong because we can see CO2. We know the
Can't see
particulates
a
that
neutrino.
we need. We know the particulates that we need to spray in the sky and look through it through a satellite to see the CO2.
Sean,
Yes.
look up a neutrino.
What? No, I know what a neutrino is, and I can't see it. I know.
Right, but we know they exist
Okay, but how?
because we've detected them.
Well, we detect CO2.
And I detect your cynicism.
Then we're on the same
But
page.
Yeah. If they can do the same thing that the Japanese did when they detected the neutrinos, right, with their underground detection system,
I don't
they
know what
built.
they did.
I'm explaining.
Oh, okay, just checking. Well, you said how
Yeah.
they acted, and we don't know.
Yeah, but what they did was they had these detectors, and when the neutrinos hit, the detector lit up, right? So there was something interacting with it. Okay, couldn't see it, but there was an interaction that happened. Okay, therefore, if something makes an interaction, it must exist. That's by definition. Same with gravity.
See, that's the thing.
You see the effect of it.
See, that's the thing, though. But see, I don't see it the same way as gravity, though, because I get what you're saying. We can see the effects.
Yeah, that's the same with this graviton. You see the effect of the graviton. Because it affects something, there must be something that causes the effect. Not cause and effect. Not cause and effect.
See, it did it again.
Yeah.
I get it. I see what you're saying now. Okay.
Yeah.
So it's not. So in a sense, even the graviton, like we were just discussing, in that sense, exactly. Okay. Yeah. Just what you're about to say. We keep seeing an effect of something, and we're calling it a graviton. Or no.
Yeah.
Well.
Yeah.
But see, the way that
was the same thing with the photon packet that Einstein discovered.
But the guy on that what link you sent me, the way the guy explained it was in a sense of like there are some the way we find out what a particle is or these different particles are is that interaction. The bing, something happened. Well, for it to be
like
something, it has to bing 100 out of 99 times or 99 times out of 100, right?
Yes.
Nope.
But the graviton hasn't binged
Quiet,
once.
Barney. He's making an analogy.
But it hasn't binged. It hasn't binged once, though, right? And this is that theoretical light that he was just talking about.
Yeah.
And it hasn't.
There's bigger problems than that.
Like what?
Barney,
That is that there is no working theory for gravitons.
Yeah. So not only is there no light that ever has binged, they haven't. There's not even a reason to see. That's what confuses me, because to say that there's not even a reason to be even talking about it, or hypothetically speaking,
hypothesized.
There you go.
You're welcome.
Bing. Yeah, there you go. There's like it's like you're almost saying, Barney, there's no reason for it to be hypothesized ever, but there is, though, right?
No, there isn't. Well, so
damn. See, I'm all confused.
A little while ago, I was trying to explain that very thing to you, right? Where if you just take the other forces that we do know and that have detected particles, and you say, well, I suppose that gravity is the same thing, but gravity, right? Then I know what the field tensor for gravity is, therefore I can predict the spin of that particle. I know, like, those things you can just deduce if you make that assumption. However, that does not mean that you have a functioning theory, right? That does not mean that you can actually work it out to give you any results. And there are theories that involve gravitons, like proposed theories, which have effectively already been disproven because they don't work, because they fail either at the general relativity model, or they fail at interfacing with the general relativity model, in which case you have a graviton which doesn't explain gravity, or they don't interface with the quantum model, in which case you don't have a boson and you don't have a bosonic force, and then it's not a graviton. Right? And string theory is, like, literally one of its parents was the proposal of a non-particle particle, of non-point particle, right? If
You mean 0 point energy?
If we just point it, no. If we just say that it cannot be a point and it cannot interact as though it were a point particle, and just spread it out a little bit and make it a little loop of something, then there are ways of renormalizing that. If you take just a point particle under the tensors of gravity, you cannot renormalize it. You get infinities, and the whole thing just falls apart. So a couple of decades later, they were trying to figure out the strong force, and they used a similar idea of strings and loops, and found mathematics that would describe gluons as these little strings that connect things. And they got this pesky outcome of this really weak loop particle which would be attracting everything that they were trying to get rid of. And somebody said, hey, wasn't that exactly the thing that we were trying to find a couple of decades ago? Maybe this mathematical abstract artifact which is messing up with us is a gravity. And that's how string theory even became the candidate for, oh, if that's so, we could have a potential candidate for connecting quantum theories to general relativity through this loop, string-like loop thingy that could then take the place of a graviton, which is not a particle.
Now, is it possible that so see, this is what confuses me, because now that I understand a little bit more about when you're talking about on the quantum level, are they looking for something that interacts okay, better way of saying it, the theory of everything, is that a human made up, like they're looking too hard for everything to match, or is there a possibility that on smaller than a quantum level, things just do not work the same? Like they're always looking.
You're talking about
the unification,
unified field, unified field theory. To the best of my knowledge and understanding of all this, because you have things like string theory, cosmology, electric universe, and all that, how are you going to unify the three when each of them uses a different property to make their explanation? So electric universe believes that everything's to do with plasma. And hang on, let me make the point. Come on, I'm on a roll. Okay. Electric universes uses the electromagnetic spectrum and basically plasmoids and all that as the interactions that planets and galaxies have. String theory predicts that inside even a quark, there's a little piece of string, which they haven't shown to be true because you can't see it. Okay, that's their thing. And to say that there's 10 dimensions, I mean that and plus time, that just like people have enough trouble with Einsteinian fourth dimension.
Yeah, but in the sense of that, if there is 4, and we can't see that fourth, isn't that to say that then why couldn't there be 11 and we just can't register? Period.
Yeah, but the fourth is causality, right? Think of it as causality, not just time. Okay, so it's from event to event to event. That fourth dimension is the fact that something happens here, then something happens there. There is a duration between those events. And that happens with every event. There is always a duration. That is the time of space-time.
Yeah,
from event to event to event to event, right? Once you get to the 5th dimension, 6th dimension, 7th dimension, it gets a bit kooky. Yeah, they explain it well and all that sort of stuff. But isn't it that the layman, which we are referring to, which is most of us, we're struggling to get around space-time, and yet string theory wants to add 6 more dimensions.
Let's be honest, we're struggling about classical Newtonian physics.
I know I am.
Says Barney.
Yeah,
says Barney.
Yeah, he's a little puzzled.
Yes. Says Barney.
Yeah, Barney. Barney's the authority. Just picking.
Well, he was mine. I told you he's my god. So.
well, there's actually a push now in Australian schools to do away with the Newtonian physics. I mean, still teach bits and pieces of it, but to move to the Einsteinian physics in schools.
Isn't that more college level?
Well, skip Lagrangian altogether.
No. So what they're saying is, teach the kids about equal and opposite reactions and all that sort of stuff in early primary school. Then once they get to middle primary school and about to transition into what you guys call middle school, or because we only go from primary school to high school, those transition years, which is 6 and 7 here in Adelaide, and then to 8 and 9. that's when they start teaching the Einsteinian physics, relativity and all that sort of stuff, like, the passages of time and all those sorts of things. Because it's not being taught until year 11 and 12 here. So a child's mind's more malleable up to the ages of 12 and 13.
I love that idea.
Yeah.
That's a good idea. I think that's the problem. Like, I think that's like, for instance, like when I came into this, I had a very general idea of what Newtonian is, and as I obviously learned and been examples, and you guys explain it more, have I just now really started to kind of have a basic understanding of general relativity and what Einstein was saying. It's school doesn't distinguish enough the two at all. They don't. I'm not saying they don't at all, but they don't distinguish between them at a time at all that I remember.
Yeah, they're both describing reality. They're just two different languages of describing it, or 4 different languages, depending on what you include into that set.
Yeah, well, so you've got the descriptive, the mathematical, the practical, and what's the other one, Barney?
What?
So you know how you said there's the 4 languages of doing the physics?
No, I was talking about Newtonian physics, Lagrangian physics, Hamiltonian physics, and Einsteinian physics. Those are the 4 different classical theories, which are mutually equivalent.
Well, you need to make these statements up front, Barney. Because we're just concentrating on Newtonian and Einsteinian, and then you throw 2 other people into it. It's like, whoa, sausage party or what?
Yep, and all of them were guys.
I don't want to hear about that shit. Fuck you guys.
Don't drop the soap. I didn't say that. Ignore it. All right, just ignore it. Guys, I think we're done. Done about the topic. I'm gonna keep them short. I don't want it to span out. Matter of fact, I don't want my brain to hurt. But I mean, if you guys have more to say about it, please keep going, because I'm interested. But I will not be able to carry on the conversation without doing long pauses and looks at the sky like I am right now.
Did we fry your brain?
No, you didn't, but yes, it is. If that makes sense, then you're on the same page.
That's right. It's still Tuesday, isn't it?
Just remember how nice it is to actually be able to look up.
Asshole,
and
it's Wednesday.
See the damn.
Wait, is it Wednesday? Fucking digital.
Not yet.
Hang on.
I know what time it is.
Oh, yeah, it is.
You're still in Tuesday.
Yeah, it is Tuesday. No,
Yeah.
See, yeah.
Puff, puff, pass.
See? Yeah, exactly. And that is why we're done. I probably.
Oh, yeah, and Blue.
I think Blue left.
I didn't say not teach Newton. I said.
I see. To bacon God, no.
No bacon God. No.
Nope.
That's it. Delete the message. No.
Yeah,
Get rid of it.
Happen.
No.
Yeah. Do you guys want to do? I'm still gonna. You got anything final to say? Digital, you want to go first?
Yeah. This is so much better. That all we did was throw an idea, talk about it. Didn't come to much of a conclusion, but we got somewhere.
Yeah, it doesn't have to. There'll be more to be said. Well, it has to be, because it's a lot to know.
And by the way,
if we did reach much of a conclusion on this topic, there'd be Nobel prizes in it.
Ooh, we did come to a conclusion.
Yay!
We did.
Yeah, we
came
got
to
a conclusion. Where's my prize?
No. We did come to one. You ready? I will not discover the graviton.
You will not discover the graviton.
I will not.
By the way, I have to show Terry
I
Davies
believe
will be
that you
going
will
live
not
later.
discover a graviton. You might prove me wrong.
No, I won't. Trust me.
Don't be so negative.
No. Unless I bump into it, I won't. Barney, do you want to?
Doc Brown invented the flux capacitor when he fell off his toilet.
Barney, did you want a final word?
Nah, I'm fine.
Okay. Sean.
It's not billiard balls, Sean.
I get it. I know now. But I have to use something to have an idea. But I promise you, when I do discuss it, I will forever make sure that I say in every direction, infinitely in every direction, everywhere it could be. I remember that part though. That's another thing I learned. I have to make sure I clarify that because the waves or the ripples in water do not depict the level of scale of infinite it is. I get it. Maybe that should be my new god, the graviton.
What? No, after show. What? Terry, what are you doing? Terry.
Oh,
Terry.
Well,
Terry.
Hang on, let me see who's over at on. Hang on, I gotta hear it real quick.
Hello, C4.
I think.
Bad shout out to Jimmy and thanks for the candy bars.
This image here.
All right, now.
Sure.
Just looking at the upper targets that are in line.
Yeah, I never mind. I was gonna say I was gonna be over at I was gonna go over to Jose's voice chat, but George is talking right now. Dude's smart as shit, but holy crap, it takes forever. You got to be committed to what he said. So I'll probably be hanging out somewhere. Crash. You had a very, 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 very shitty situation happen. Tomorrow we're going to talk about it. But do you want to give the people the basic of what's going on? Of what happened?
So the basic rundown is certain people wanted to update files. And since they couldn't do it themselves, they sent a local sheriff to find out if I lived at the address I had listed. And then I magically had a 5-year-old and a 7-year-old traffic warrant pop up, and I spent the weekend in a holding cell, or the week in a holding cell, because I refused to answer questions.
Yeah, I can tell you right now that that's BS because I've had, especially a warrant that's 5 years out. I've had it, and it was again for traffic stuff. They just want you to take care of it. Usually just give you a nice little piece of paper that makes sure you know that you had that court date. But yeah, the way it is, and again, there's a little bit more into it. But it was tomorrow. I want to go into it, and then you wanted to talk about it's what happened during, before, during, and after that situation, basically, right?
Yeah, it's the American justice system is all about a profit. It was literally, for me to call my old lady for 5 minutes was $20 for a 5-minute fucking phone call.
Yeah, and that's just, and it's more than just, it costs that much to talk to your girl? Well, imagine what, a lawyer or, what I mean, or someone that was there that can tell them, hey, this is how it really, like, it's bigger than just, it was just my girl, but that's, his situation. And,
or let's put everybody here's had ramen noodles, right? How much they cost you to go to the store and buy one package of ramen noodles?
I believe last time I bought them, it was 33 cents, 32 cents, something like that. For like one.
Yeah, how about for $5, I got one ramen noodle, a candy bar, and a 1 cup of coffee.
Wow. Commercialized, huh?
The whole system is like they have even at the county level now, it's all integrated to this fucking company called Securus, which I'm doing some research on tonight, that controls everything in there. They control what you can get on commissary, what you can get for hygiene products, who you can call, when you can call them, how much it costs you to call them, because I found out that if you're in the prison system longer, it costs you more money or less money to call them, depending on how you're ranked in the prison system.
What the?
Oh, yeah, it was fucking stupid.
Yeah, definitely tomorrow. And I'm gonna message. I'll message you in on Discord just so we can make sure we got the right times and everything. Because I definitely want to talk about that because and then again, it's your situation, which is effed up. But it's actually a bigger situation because I wasn't until about 5-10 years ago. My uncle was working on a project out in El Centro out here, and they were building a prison, and that's when I got the idea. Like, I was talking to a couple of the administrators that were out there just checking the place out as the construction was going on, and they made it pretty clear. And that was the first time I ever realized that prisons are a business. And that's basically all they are. It's like the prison. It's the prison is the business, and the business is holding the state and the federal levels prisoners.
Yep, it's all business. It's so. Talking to some sergeants and shit over the weekend, if they hold me for 5 days, which is exactly how long I was held for, they get paid for having me there for an entire month.
Damn, that's kind of like school attendance. The schools only get paid if the butts are in the seat.
So if they sentence you, like before they send you to the actual state level corrections, if they sentence you at the county level here, if they have you for more than 30 days, they get paid for having you 6 months. If you go to the Department of Corrections here and they have you for 6 months, they get paid for the entire year. So every 6 months they have you, they get a year's worth of whatever they think you're worth.
Yeah, that's what is it again? You know, remember how I always say like the climate shit with oil companies? Why would they put themselves out of business? Why would a prison rehabilitate somebody?
Oh, it gets worse than that. So they get a large, substantial sum of money for having you, but they're only required to feed you the bare minimum amount of calories to keep a 200-pound person.
Yeah.
So
there's a lot of things, but I'm gonna get out of here. But Crash, we're gonna do that tomorrow because again, that is actually a really big situation that needs to be talked about, and it actually you are actually one of the reasons that my view of prisoners in general have changed, because you do get this idea and you think, well, if you're in prison, you're probably there for a reason, and you have encompassed in just your personality and the way you talk about it as well, that you were in prison for a good reason, but what you did then doesn't make you now, and it really changed my view of how prisons are worked and how they should be, really. So respect
exactly,
to that as well.
but it's amazing how all that shit that I did and I copped to and I did my time for it, they still find ways to fuck me over now that my life is going good and I got the business running good. They still find ways to fuck with me for absolutely no reason other than to get money from me and fuck with me.
Yeah, and I've heard. I used to hear that.
I'm a convicted felon. Mm-hmm. What the fuck can I do? If I try to fight them, I get fucked either way.
Yeah, because I used to think, well, it's your problem, dude. You did it. But the idea that it's that they do make money on you being in their system. They don't give you. They give you what I've seen and researched. The first, maybe your freshman and sophomore year of high school worth of education and knowledge about how to get out of prison and make it, basically. It's very much so. Are they looking? Oh, they are. Teach them. Not looking. Fuck them. That's what it feels like. That's why I don't think rehabilitation is one part of what they need or what they want. I mean.
Oh, it's not. They want you to go out and reoffend, because if they release you, so if they release you on parole and you go out and you fuck up again, they get paid. You have to pay them for all the time you were on parole. So if I was on parole and I fucked up I have to pay them for all the time I was out. All the time they missed
It's like a bail.
is now a fine. And then I got to turn around to do more time that they're going to get paid for on top of it anyway. So after you're in once, you're just a number and money to them.
Yeah,
period.
They want to just jump into your world and go, hope he's fucking up. Boom. Oh, yeah, he is. Cool, money. And that's why they check on him. And it's not because, again, checking on somebody is like, it's like checking on someone who hasn't done anything. If you're on parole, yeah, that just should only really mean that if you commit a crime, that goes to your sentence, the one that they released you on, basically. But it's very much so what you did sticks with you until we say. And I've heard some crazy time. Like a buddy of mine, his brother actually they were involved in a DUI accident. And he served, I think it was 18 years. And after that, he went on parole for, I think it was 15 years. And he had a no alcohol policy. And he had to fucking test once a week. And he did that whole testing for, so far, I think he's done 14 years now. And it's like, why? And like you just said, all those visits, all that means to anyone is if he messes up, he becomes back in our system. And we get that much more money. And the sad part is that's how the prison systems, that's how they look at it.
Yeah, they don't want to rehabilitate you. They want to get you in. They want to have you just long enough to get paid as maximum amount they can. Then they want to kick you out thinking that making you think that you're going to do something and be better, just so they can pinch you on something stupid and start the whole process all over again.
Yeah, and that's kind of like one of the situations of decriminalizing, at least in California, decriminalizing like marijuana, for instance. It's not something that ever goes to court. It's not something that if you are convicted of it, you're going to get any real time. And what was happening is the prisons were filled with people that were just for really minuscule drug charges, and then say Joe Schmo and 10 of his fucking terrorist buddies go out and do some fucking shooting. The prisons that have all these potheads in it, they don't get them. That's what all the fucking releasing all the potheads and all that shit was about. It wasn't about, oh, they haven't done anything. No, they make more money if their prisons are open to those other crazy motherfuckers. That's what that shit was about. And that was a crazy part.
That's exactly it. Like, I can go in, my buddy's a gunsmith. I can go into his shop, but I can't buy, purchase, or touch anything. I go there because he carries polishing compounds I need. But they have me on camera going in there, and they automatically assume that I'm in there doing something.
Yeah, it's ridiculous. I mean, and they go at you like you did something, not just want to look around real quick, leave you alone. Because I've had buddies that were on probation, and cops are assholes. If they think anything, they'll fuck all your shit up and find nothing, and then just go home. They'll just leave. All right, bye, guys.
I've had my motorcycle ripped apart on the side of the highway. I've been pulled over for absolutely no reason, just because they ran my fucking name, and it came back that I used to be affiliated. No reason. They'll stop after they've completely ripped my shit apart.
Yeah, that's ridiculous.
And there's nothing I can do to fight it because they were within their 72 hours on shit.
Yeah, that's ridiculous. All right, Gosh,
we'll go,
man.
We'll go into it more tomorrow.
Yeah, I'm starving, man. My stomach is grumbling and I can't concentrate. Excuse me. But yeah, we're going to definitely go tomorrow about it.
Pizza from Casey's, so.
Huh?
I just ordered my fat kid pizza from Casey's.
Yeah, see, that's why I got to go, because I'm hungry. But yeah, stick around, because I'm not going to leave the hangout. I'm just going to mute it real quick.
Yep.
All right, guys. Like I said, nothing's going to change. Like I said, man, I'm not going to entertain any bullshit. If we're going to talk alternative ideas, we can think tank the fuck out of it. Sounds good to me. I don't mind at all. But I really cannot entertain just complete crap. Again, guys, I appreciate everyone that stuck around to figure out what's going on, or even just to be here. But again, thank you. One of the things I also wanted to preface with this whole situational change of platform and everything. Again, I'm not disappearing. I'm not gonna not talk about it. It's just not gonna be here, guys. Today was a perfect example of exactly what I hope everything continues to be, in a sense that it doesn't need to be serious the whole time. Even if it's an idea that's not a realist, like not actually here, like the Graviton. There's no evidence for it. It's still good conversation. You can have that conversation about any topic, and it doesn't need to lead to those other unethical, thought processed ideas, right? So again, it's not going to be difficult. Again, that's how it works, and it's going to continue that way. I appreciate it all. Tomorrow we're going to go into a crash, like we were just talking about with what happened over the week, and also I'll let you guys know what I'm doing with the whole demonetizing, but still have the super chat up and everything, because that's not going to go to me anymore, and I want you guys to understand what's going on. So thank you all for being here. I appreciate it. There's going to be a lot more things to come. Probably going to be doing some more interviews, and definitely look out for uploads. One of the things that I was saying before is that I'm a very visual person, and when an idea is visualized to me and explained, I understand it better. So I'm gonna start doing some uploads that kind of just show how I visualize it to get a better understanding, and we'll go from there. But thank you guys, I appreciate it. See you guys tomorrow.